Hey everyone, in this tutorial we'll talk about vectors. How do we plot a vector, vector addition, vector multiplication, and how do we plot a vector using Numpy and Matplotlib in Python. So let's get started. Vectors and vector spaces are fundamental to linear algebra. They are used in many digital technologies like machine learning models and for data manipulation scenarios. Vectors describe special lines and planes that enable you to perform calculation that explore relationship in multidimensional space. Vectors are usually denoted by a lowercase letter and with an arrow above them to indicate a direction. Here I have described two vectors. One is a 2D vector and one is a 3D vector. The vector itself consists of set of values to describe length of direction or amplitude and length or magnitude. You can think of the values of a vector describing the route that you must take from an arbitrary starting point to an end point. Now in this scenario, we will plot the vector's Cartesian plane. Our vector v has two dimensions and it tells that we need to travel 3 units in one direction. So we'll travel 3 units in one direction and we have to travel 4 units in another direction. So we get to a point. So this is our vector. Similarly, we can plot this in the three-dimensional coordinate plane. Now let's talk about vector addition. Let's say we have one vector u that is 5, 1 and we have another vector v that is 1, 5. Okay, so we'll plot this u vector here. So first is 5, 1. So this will come around here. Now 1, 5 will come around here. Now these are my two vectors. Now what is the sum of these two vectors? So the sum of these two vectors can be individual sum of both the components. So we get a new vector z that is 6 by 6. Now we can plot this addition of these two vectors in this plot and we get something around here. So this is a new vector z that is the addition of these two vectors. Let's say we have one vector v that is 1, 2 and we have another vector u that is 2, 3. Now there are three types of vector multiplication. One is scalar. In scalar multiplication, we just scale the value of the vector by that number. So if I say a scalar vector of v by 3, so 3 times v, so the scale it becomes 3 by 6. So the scalar value is a scalar multiplication of v is 3 by 6. Now there is another multiplication that is dot product. In dot product, we calculate the scalar value as a result. To calculate the dot product, we multiply the corresponding element of the vector and add the results. So for dot product of these, what we'll do is multiply these two values and add the result. So dot product of the above u dot v becomes 1 into 2 plus 2 into 3. So it becomes 2 plus 6. The dot product of this is 8. The third kind of multiplication is to calculate the cross product of two vectors. This produces a new vector that is perpendicular to the original two vectors in a three-dimensional space. So it really makes sense to use a three-dimensional vector to calculate a cross product. Now to calculate the cross product, you need to calculate the individual element of the resulting vector. You might see a formula for calculating the individual elements of the resulting vector on your screen. We will use this formula to calculate the individual elements of the resulting vector. Now this is the calculated cross product of our two vectors. Now let's jump into the Jupyter notebooks and let's try some hands-on with vectors. So first we'll plot a vector in 2D space. For this we will import our necessary libraries. So as discussed in the last tutorial, we'll use Numpy and Matplotlib. Numpy to basically store and create our arrays, and Matplotlib to plot whatever vector that we create. We will create a vector v, which is a NumPy array having the values 2.4. Now we'll create a subplot and we'll use ax.plot function to plot the vector. Now we set the origin of the vector as 0. So the first value, which is the x value, we'll set as 0, v0, and then the y value is 0 and v1. Now let's plot a vector in a 3D space. For this we'll use the same code base and we will build on top of this code. For creating a 3D plot, we need a 3D library. So we'll import the Access 3D library. Now let's create a 3D vector v using np.array. Now we'll use ax.plot and plot our 3D vector. We get a 3D vector in the 3D space, but we still are not able to correctly assume the coordinates. Now let's create a reference coordinate. Now let's create a reference coordinates so that we are able to visualize our vector correctly. Now we can see our vector with reference to the base vector. Now let's use the same code base to try out vector addition. So we'll create two vectors. So our initial vector v and a new vector u. And first we'll plot these vectors and then we'll see the addition of two vectors. Now we'll plot these two values and we see we have two distinguished vectors. Now we'll add these two vectors and see what our resulting vector looks like. Now we can see the resulting vector. Now let's try out the dot and the cross product of a vector. So first we'll create a vector. This is a 3D vector u, and we'll create a new 3D vector v, and we'll use numpy functions to calculate the dot product and the cross product of these two vectors. We see, as we discussed, like the dot product is the scalar value and as cross product is a vector value. If you're using the Jupyter notebook, you will see all these exercises. There are two exercises that you can do with pen and paper, and you have a coding exercises in which you have to complete the functionality that is described in the question. Now, once you run the cell, you will see the scalar dot product and the vector cross product of these two vectors. So that was all about vectors. In the next tutorial, we'll talk about matrices. Till then, goodbye.